Welcome all T.Y.B.Sc student in our first online lecture. So T.Y.B.Sc semester 5 consists 5 subject. First one, physical chemistry. Second one, inorganic chemistry. Third one, organic chemistry. Fourth one, analytical chemistry. And fifth one, applied chemistry, that is drug and dyes. Okay, so T.Y.B.Sc chemistry consists of 5 subjects: physical chemistry, inorganic chemistry, organic chemistry, analytical chemistry, and applied chemistry. So today we discuss or we started lectures on organic chemistry. So subject number is 403, that is organic chemistry. So in organic chemistry consists 4 units. So semester 5, this is a textbook of organic chemistry. Semester 5, it consists 4 unit. So unit first consists mechanism of organic reaction and photochemistry. Unit second consists stereochemistry first and agrochemicals, heterocyclic chemistry. Then unit third consists IUPAC nomenclature and synthesis of organic compounds. Fourth unit is spectroscopy and natural product. So let's see one by one. So unit first is mechanism of organic chemistry. So mechanism of organic chemistry consists basic terms and concept, that is bond fission, reaction, intermediate, electrophiles, nucleophiles, ligands, base, electrophilicity versus acidity, and nucleophilicity versus basicity, that is the difference between electrophilicity and acidity and nucleophilicity and basicity. So 1.11, now the 1.112 is neighboring group participation in nucleophilic substitution reaction, that is NGP reaction. NGP reaction consists participation of lone pair of electron, kinetic and stereochemical outcome. Unit 1.13, it is acyl nucleophilic substitution, that is tetrahedral mechanism catalyzed by esterification of carboxylic acid. that is AAC2 mechanism, and base promoted hydrolysis of ester, that is BAC2 mechanism. And last part of unit 1.14 is pericyclic reaction, classification and nomenclature. So electrocyclic reaction, that is ring opening and ring closing reaction, cycloaddition reaction, sigma-tropic rearrangement, group transfer reaction, cheletropic reaction. So mechanism of organic chemistry is totally concept consist of the terms that involves in organic reaction mechanism. So mechanism of organic reaction, that is bond fission, means it is a breaking of bond. So how A bond is break, or how AB bond is break, that is homolytic bond fission and heterolytic bond fission, we have to see in this point. So next one was reaction intermediate, that is, for example, A gives B and then B gives C. So B is an intermediate. So how that intermediate form, so how the stability of intermediate it increases or decreases, we have to see in this point. So next point is electrophilicity and nucleophilicity. So electrophilicity means electrophilic. Electrophilic means electron deficient, that is deficient of electron. Next one was nucleophilic, that is nucleophile, Nu minus, it is an electron rich species. So nucleophile consists numbers of electrons, and electrophile it is an deficient of electron. म्हणजे इलेक्ट्रोफाईल यांना इलेक्ट्रॉनची आवश्यकता असते आणि न्यूक्लियोफाईल यांच्याकडं इलेक्ट्रॉन्स असतात. नेक्स्ट कन्सेप्ट वॉज ligands and base, that is ligands terms we can also seen in inorganic chemistry, and base concept, it is an, as you know, NaOH, that is OH minus ions, it is a basic condition, so it is an base. Then we have to see electrophily, electrophilicity versus acidity. There is a difference between electrophilicity and acidity, and difference between nucleophilicity and basicity. Okay, next point is NGP, that is neighboring group participation reaction. So in the neighboring participation reaction, we have to see the nucleophilic substitution reaction, that is any molecule contains a lone pair of electron which attacks on another groups to take a substitution, so it is nucleophilic substitution reaction. Then we have to see the accept, that is kinetics and stereochemical outcomes of the NGP reaction, that is neighboring group participation reaction. Okay, so just remember NGP, that is neighboring group participation reaction, is take place in only one molecule, म्हणजे एकाच मोलिक्यूलमध्ये ही NGP रिॲक्शन होते. त्याच मोलिक्यूलमध्ये एक लिव्हिंग ग्रुप असतो आणि त्याच मोलिक्यूलमध्ये एक अटॅकिंग ग्रुप असतो. त्याच्याकडे काय असते, लोन पेअर ऑफ इलेक्ट्रॉन असते. व्हॉट इज मीन बाय लोन पेअर ऑफ इलेक्ट्रॉन? इट इज अन सिम्पली नॉन बॉन्डिंग इलेक्ट्रॉन. Okay, so next we have to see acyl nucleophilic substitution, that is acid catalyzed restriction of carboxylic acid and second part is base promoted hydrolysis of ester, that is BAC2 mechanism and AAC2 mechanism. So we have to see in this point the difference between AAC2 and BAC2 reaction. So now next part is pericyclic reaction. So pericyclic reaction consists electrocyclic reaction, that is a part of pericyclic reaction are one step reaction. Remember always, pericyclic reactions are one step reaction. So now the pericyclic reactions are divided into electrocyclic, that is pericyclic reaction are divided into electrocyclic reaction, okay, cycloaddition reaction. Next part, cycloaddition. Next part of the pericyclic reaction is sigmatropic. Then pericyclic reaction are divided into group transfer, and also it consists cheletropic reaction. Okay, so next in the details of the lecture, or in the unit first, we seen electrocyclic, cycloaddition, sigmatropic, group transfer reaction, cheletropic reaction in details. Now today we just overlook on the our syllabus. So next one was pyrolytic elimination, that is Cope elimination, Chugwe reaction, and pyrolysis of acetate. Okay, so next point of first chapter is 1.2, that is intra photochemistry reaction. So next point is photochemistry. Okay, so photochemistry consists difference between thermal reaction and photochemical reaction, Jablonski diagram, singlet state of the molecule and triplet state of the molecule, allowed and forbidden transitions, fate of excited molecules, and photosensitization. So most important part in photochemistry is Jablonski diagram. So how the relaxation of the molecule is take place. Okay, so process A, process B, process C, process D, it's involved in Jablonski diagram. So singlet state and triplet state, it is spin state of that electron. We have to see in photochemistry in details that singlet state and triplet state, the allowed transition and the forbidden transition. Second part is photochemical reaction of olefins. So what is meant by olefins? Olefins means carbon carbon double bond or carbon carbon triple bond containing compounds. That is the olefins. So in olefins we have to see photoisomerization, photochemical rearrangement of 1,4-dienes. So what is dienes? Ins means, or in means double bond, and dienes means two double bond. So 1,4-dienes, that is diphi methane rearrangement. Okay, Next is photochemistry of carbonyl compounds. The two main types of reaction, Norris first and Norris second cleavage. And the last part of the photochemistry is photoreduction. So what is by reduction? What is by reduction? Reduction have three definition. First one was addition of electron. Second one was removal of oxygen. Addition of electron, removal of oxygen. Last definition of reduction is addition of hydrogen. So in this chapter we needed addition of electrons, that is reduction. Remember, reduction is consist of three types, that is addition of electron, removal of oxygen, and addition of hydrogen. Okay, so now we move toward the unit second, that is stereochemistry. So stereochemistry divided into two parts. Stereochemistry first part in the semester 5 and stereochemistry see here, stereochemistry second unit first, that is 603 in semester 6. So we have to see stereochemistry first in semester 5, then stereochemistry second in semester 6. So stereochemistry consists molecularity, molecular chirality of an element. Unit second consists stereochemistry, that is molecular chirality and element of symmetry. It consists mirror plane symmetry, inversion center, rotation, reflection axis. That is, it's a part of symmetry, and this symmetry we also seen in inorganic chemistry. Okay, so next part is chirality of the compound without stereogenic center, that is cumulins and biphenyls. Okay, so in this point, that chirality means what is meant by chiral compound. As we see in 12th science, chiral compounds at least contain one asymmetric carbon atom. So what is the asymmetric carbon atom? The carbon atom which having a four different group attached. It is called as, this carbon is called as asymmetric carbon atom. ज्या कार्बन ॲटमला चार वेगवेगळे ग्रुप अटॅच असतील तो कार्बन ॲटम काय असतो, असिमेट्रिक कार्बन ॲटम असतो, आणि तोच कार्बन काय असतो, कायरल कार्बन असतो. पण ह्या चॅप्टरमध्ये आपल्याला काय बघायचं आहे, कायरॅलिटी ऑफ ए कंपाऊंड विदाऊट स्टेरिओजेनिक सेंटर. म्हणजे हा जो कार्बन तुमचा आहे, हा कार्बन काय आहे, हा स्टेरिओजेनिक आहे. पण काही कंपाऊंड असे आहेत की ज्यांच्यामध्ये हा स्टेरिओजेनिक कार्बन ॲटम नसतो, तरीसुद्धा ते काय असतात, कायरल असतात. ते आपल्याला कुठं बघायचं आहे, 2.1.2 ह्या पार्टमध्ये पाहायचं आहे. नेक्स्ट 2.2 इट इज एन agrochemicals. So agrochemicals consist general introduction and scope as we seen in agriculture. Next, insecticides, herbicide, fungicide, rodenticide, pesticide, and plant growth regulators. Okay, next we have to see advantages and disadvantages of agrochemicals. Synthesis and application of IAA, that is indole acetic acid and indosulfan. And last point is biopesticides, that is neem oil and orange oil. Okay, so last part of the unit 2 is 2.3, that is heterocyclic chemistry. It consists mainly reactivity of pyridinium oxide, quinoline, and isoquinoline. So in SY chemistry, we seen heterocyclic. So heterocyclic, that has the amines. So in SY chemistry, we seen amines. That is nomenclature of amines, primary amine. So what is meant by primary amine, secondary amine, tertiary amine, then reactions of amines. So how amines are synthesized, what is the reactions of amines. So this topic, that is relative to heterocyclic chemistry, the basic topic consists in SY chemistry, that is heterocyclic chemistry. So now further advanced part of that part is include in T.Y.B.Sc chemistry, that is reactivity of pyridine N oxide, quinoline and isoquinoline, then the preparation of pyridine N oxide, quinoline. So quinoline consists scrap synthesis, then isoquinoline synthesis. Next part is reaction of pyridine N oxide. So halogenation reaction, nitration reaction, reaction with soda amide in liquid ammonia, that is NaNH2 in liquid ammonia, and reaction with N-butyl lithium. N-butyl lithium, it is can act as a base. Last part of the chapter is reactions of quinoline and isoquinoline, oxidation, reduction, nitration, halogenation, and reaction with NaNH2, liquid ammonia, and N-butyl lithium. So as we seen in this, in heterocyclic chemistry, we totally focused on three compounds, that is pyridine N oxide, first one. Second one was quinoline, and the third one was isoquinoline. Okay, so pyridine N oxide synthesis and reaction, quinoline synthesis and reaction, and then isoquinoline synthesis and reaction. So these three, mainly three compounds consist in heterocyclic chemistry, that is Ty heterocyclic chemistry. Okay, so now we move toward the unit 3. Unit 3 is, first part is IUPAC nomenclature. So IUPAC, it is an international union of pure and applied chemistry. So how we can name the organic compounds, we have to seen back in the FY chemistry. Now here we discuss the nomenclature of bicyclic compounds, that is pyro compound, fused compound, or bridged compound. Then biphenyls compound, then cumulines up to 3 double bonds, and then quinoline and isoquinoline. So nomenclature, it is a very basic chapter, that is the naming of organic compound. Okay, next 3.2 is synthesis of organic compounds. So synthesis of organic compound consists linear and convergent synthesis. Then criteria for an ideal synthesis. Then concept of chemoselectivity and resioselectivity with example, and last calculation of the yield. So synthesis of organic compound 3.2.1 consists mainly chemoselectivity and resioselectivity. It's most important part. Then 3.2.2 is multi-component synthesis, that is Mannich reaction, Biginelli reaction, synthesis with example. And then the next part is green chemistry and synthesis, that is 12 principles of green chemistry. concept of atom economy and E factor calculation and their significance, and the numerical problems. Green reagent, that is dimethyl carbonate, and green starting material, that is T glucose, with green solvent supercritical CO2, and green catalyst biocatalyst. Okay, so in the green chemistry, that is unit 3, green green chemistry, it is totally basis upon the how, for example, the compound A to give compound B. So how the reaction as we can make in green environment, that is green reagent, green starting material, green solvent, and green catalysis. Okay, and next part is planning of organic synthesis, that is synthesis of some nitroanilines, synthesis of halobenzoic acids, alcohols, and using Grignard reagents, and alkanes using organolithium compounds. So planning of organic synthesis, it is an some of the basic part of retrosynthesis. So how the compound is prepared, as we know the meta, for example, nitroaniline, ortho or paranitro. So this is a structure of aniline. So here the ortho position, that is NO2, that is ortho nitroaniline, and here the para position, that is para nitroaniline, and here the meta position, that is meta nitroaniline. Remember, this compound is ortho, this compound is para, this compound is meta. म्हणजे ऑर्थो म्हणजे काय असणार, ऑर्थो म्हणजे 1-2 पोझिशन, 1 आणि 2. पॅरा म्हणजे काय असणार, 1-4 पोझिशन, 1 2 3 आणि 4. ओके, मेटा म्हणजे काय असणार, 1-3 पोझिशन, सो 1 and 2, 1 2 and 3. So 1-3 means meta position. So in the chapter unit 3, you can briefly study what is ortho nitroaniline, what is para nitroaniline, what is meta nitroaniline, and halobenzoic acid also. Okay, and last unit is consists spectroscopy. So spectroscopy also divided into two parts, as we seen the unit second. Stereochemistry consists first, and stereochemistry second in the unit consists semester 6. Okay, as that spectroscopy first in unit 4 in the semester 5, and the spectroscopy second unit 3 in semester 6. Okay, so in this semester we have to see spectroscopy first, and spectroscopy 6 is in the semester 6. So spectroscopy first consists electromagnetic spectrum, that is UV radiation, IR radiation, X-ray, gamma rays, far IR, near IR. So this type of spectrum, that is magnetic spectrum, which consists both electro and magnetic. So it is an electromagnetic spectrum, units of wavelength and frequency. So as we seen wavelength and frequency in the 12th science. Okay, next part is UV visible, that is ultraviolet visible spectroscopy. basic theory, solvents, nature of UV spectrum, concept of chromophore, auxochrome, then the bathochromic shift and hypsochromic shift, hyperchromic shift and hypochromic shift, then chromophore and chromophore auxochrome interactions. You can see in the spectroscopy first, and the next part is mass spectroscopy. So mass spectroscopy is totally basis on the fragmentation of the molecule. So spectroscopy, it is one of the most basic tool in the detection of structure. In the details topic, we have to see all these point. Okay, next is NP, that is natural product. So natural product is terpenoids. The terpenoids, introduction of terpenoids, that is classification is there. Then isoprene rule, the basic unit of terpenoids is isoprene. So nomenclature of isoprenes, there are some rules. So isoprene rules and the geminal dialkyl rules. Then citral, so synthesis of citral, structure of citral, then isomerism in citral. The next one is alkaloids, so introduction and occurrence, then Hofmann exhaustive method and degradation in simple open chain and n separate monocyclic amine. And the nicotine, as we know, nicotine, it is a content of our tobacco. So the structure determination of nicotine, synthesis of nicotine from nicotinic acid, and harmful effects of the nicotine, as we know, it consists in tobacco. Okay, and the last one, that is a hormones, introduction, structure of adrenaline and the physiological action of adrenaline, the synthesis of adrenaline from catechol and para-hydroxyaldehyde, that is wood synthesis. So today, in the today's lecture, we have to see the organic chemistry. Organic chemistry mainly consists of 4 topics, as we seen starting our lecture. आता सुरुवातीला आपण बघितलेलं आहे की ऑर्गॅनिक केमिस्ट्रीमध्ये सेमिस्टर 5 साठी 4 युनिट्स आहेत. सो फर्स्ट युनिटमध्ये काय काय आहे, तर मेकॅनिझम ऑफ ऑर्गॅनिक रिएक्शन, फोटोकेमिस्ट्री. सेकंडमध्ये काय आहे, स्टेरिओकेमिस्ट्री फर्स्ट, ॲग्रोकेमिकल्स आणि हेट्रोसायक्लिक सिंथेसिस, दॅट इज हेट्रोसायक्लिक केमिस्ट्री. नेक्स्ट तिसऱ्या युनिटमध्ये काय आहे, IUPAC नॉमेनक्लेचर, सिंथेसिस ऑफ ऑर्गॅनिक कंपाऊंड्स. आणि चौथ्या युनिटमध्ये काय आहे, स्पेक्ट्रोस्कोपी फर्स्ट अँड नॅचरल प्रॉडक्ट्स. म्हणजे हे 4 युनिट सेमिस्टर 5 आपल्याला काय करायचं आहे, स्टडी करायचं आहे. आता ज्यावेळी आपण सिलॅबस स्टडी करत होतो किंवा सिलॅबस रेफर करत होतो, त्यावेळी तुम्हाला जाणवलं असेल की ऑर्गॅनिक रिॲक्शन्समध्ये काय आहेत, तर सिंथेसिस आणि रिॲक्शन्स आहेत. म्हणजे ऑर्गॅनिक केमिस्ट्रीचा अभ्यास तुम्हाला कसा करावा लागेल, तर त्याच्या सिंथेसिस आणि रिॲक्शन व्यवस्थित समजून घ्याव्या लागतील. त्यासाठी काय करावं लागेल, तर रिॲक्शन्स किंवा सिंथेसिस असतील तर त्या काय करा, त्याचा सराव करा पाटीवरती किंवा तुमच्या वहीवरती त्या रिॲक्शन्स लिहून काढत चला. ओके, ऑर्गॅनिक केमिस्ट्रीमध्ये रिॲक्शनला फार महत्त्व आहे. ओके, हळूहळू तुम्हाला ते समजत जाईल की ऑर्गॅनिक केमिस्ट्रीमध्ये जर आपल्याला पास व्हायचं असेल, स्कोरिंग करायचं असेल, तर आपल्याला काय समजल्या पाहिजेत, त्याच्यामधील सर्व रिॲक्शन समजल्या पाहिजेत. आणि रिॲक्शन कशा समजू शकतात, तर रिॲक्शन ह्या वाचून समजत नाही. त्यासाठी तुम्हाला त्याचं काय करावं लागेल, लिहिण्याचा सराव करावा लागेल. म्हणजे आपण तुमच्या डेमोसाठी काही रिॲक्शन इथं दाखवू शकतो. तर ही तुम्हाला रिॲक्शन इथे दिसू शकते बघा, ही स्टेरिओ केमिस्ट्रीमधली रिॲक्शन आहे. तर अशाच रिॲक्शन तुम्हाला, ही सुद्धा रिॲक्शन आहे, ही पेरिसायक्लिंगमध्ये रिॲक्शन आहे. म्हणजे ऑर्गॅनिक केमिस्ट्रीमध्ये तुम्हाला जास्तीत जास्त काय आढळून येतील बघा, ह्या पेजवरती आपण बघू शकतो की लिखाण कमी आहे. ओके, आणि नंबर्स ऑफ रिॲक्शन्स आहेत. तर ह्या रिॲक्शन तुम्हाला समजण्यासाठी काय करावं लागेल, तर घरी सराव करावा लागेल. ओके, काही थेरॉटिकल पार्ट्स आहेत. म्हणजे काय, तर फोटोकेमिस्ट्री हा जो टॉपिक आहे, फोटोकेमिस्ट्री हा थेरॉटिकल पार्ट आहे. ॲग्रोकेमिकल्स हा थेरॉटिकल पार्ट आहे. त्याच्यानंतर नॅचरल प्रॉडक्ट्स हा सुद्धा थोडाफार थेरॉटिकल पार्ट आहे. पण बाकी जे आहेत, आता ह्या चॅप्टरचंच नाव काय बघा, मेकॅनिझम ऑफ ऑर्गॅनिक रिॲक्शन. म्हणजे हा टोटली रिॲक्शन्सवरती बेसिस आहे. स्टेरिओकेमिस्ट्री ज्याचं इमॅजिनेशन स्ट्रॉंग असेल त्याला स्टेरिओकेमिस्ट्री इझिली समजून जाईल. ठीक आहे. नेक्स्ट आहे हेट्रोसायक्लिक केमिस्ट्री. ह्याच्यामध्ये सुद्धा तुम्हाला मग काय बघावं मिळतील, रिॲक्शन बघायला भेटतील. ओके, सिंथेसिसमध्ये पण तुम्हाला काय बघायला भेटतील, रिॲक्शन्स बघायला भेटतील. त्यामुळे रिॲक्शन्स या ऑर्गॅनिक केमिस्ट्रीला मेन गाभा आहे. ज्याला रिॲक्शन व्यवस्थित समजतील त्याला ऑर्गॅनिक केमिस्ट्री व्यवस्थित समजून जाईल किंवा सोपी जाईल. ठीक आहे. तर पुढच्या लेक्चरपासून आपण काय स्टार्ट करतो, तर युनिट फर्स्टमधला 1.2 स्टार्ट करू. जो फोटो केमिस्ट्री आहे, टॉपिक सिम्पल आहे. ठीक आहे. तोपर्यंत तुम्ही सुद्धा काय करा, त्या ग्रुपवरती आम्ही तुम्हाला नोट्स पाठवत आहोत या सिलेबसच्या. तुम्ही सुद्धा घरी एकदा सिलेबस वाचून एखाद्या वहीच्या पेजमध्ये फर्स्ट पेजला काय करा, तो सिलेबस व्यवस्थितपणे लिहून काढा. ठीक आहे. तर नेक्स्ट लेक्चरमध्ये आपण पुन्हा भेटू. ओके.